Three charges are located at the vertices of a right isosceles triangle as shown in figure. What is the magnitude and direction of the resultant electric field at the midpoint M of AC side? So we need to find out the magnitude and direction at here because of the resultant charges ABC. We need to find out the magnitude and direction of the electric field at M because of these three charges. For that, I need a diagram. So let me redraw the same diagram. Now, if I write the total electric field, since electric field is a vector sum, total electric field is the vector sum of all electric field due to the individual charges. So total electric field is vector sum, so that you can write E bar as total electric field equal to electric field due to charge A at M plus electric field due to charge B at M and electric field due to charge C at M. So we need to figure it out. What is the electric field due to charge A and charge B and charge C? Now try to draw the electric field at point M, resultant electric field. For that, we need a support of positive test charge. If you take a positive test charge, the electric field due to charge C is along in this direction, and electric field due to A is along in this direction. And these two charges are, so these two are equal and opposite, equal in magnitude and opposite in direction. Equal and opposite. So you can write electric field due to at A so electric field due to A at M is equal and opposite is minus of electric field due to C at M. So these two quantities equal and opposite we can expect. So these two values cancel each other. So the resultant electric field, the total electric field E equal to only the electric field due to charge B at M. Now, if you draw the electric field lines due to because of charge B at M, so this is the distance between the electric field, sorry, if this is the distance between B to M, And if you draw the electric field direction at M, so this is somewhat looks like in this direction. So that is the electric field direction. So if we figure out what is the distance between B to M, we can calculate the magnitude of the electric field. So if you write the electric field the magnitude of EBM electric field due to B at M is, you can substitute by electric field formula, it's K times charge Q by distance square. Here the distance equal to Bm square. If you can substitute the charge value equal to 2 times 10 power minus 6 by Bm square. We need to figure it out what is the length, what is the distance between B to M. For that, from figure, if you see these two angles, since it's an isosceles right triangle, so these two angles are the same. From figure, these two angles are the same, and the same angle also here we can put. So if we can draw, and this angle also becomes as 45 degrees, and these two angles are the same angles. Now from figure, if you can write the two angles, angle MBA equal to angle MAB equal to 45 degrees, and since it's an isosceles right triangle and the side MB equal to MA, these are the lengths. So since it's a right isosceles triangle and these two angles are equal, angle MBA equal to angle MAB, so you can expect that from triangular identity, the side MB equal to the side MA. Now, if you can take triangle MAB, right triangle MAB, apply the Pythagorean theorem. From right triangle MAB by Pythagoras theorem, hypotenuse square, it means AB square equal to MB square plus MA square. AB square equal to MB square plus MA square. MB square plus MA square. So we know the value of the AB. AB value is 5 square in terms of centimeters equal to MB square plus MA square. Since MB equal to MA, so you can write 2 times MB square, since MB equal to MA. So if you can calculate the value of MB equal to 25 by 2 MB square. So from that, MB equal to 5 by root 2, M equal to 5 by root 2. In terms of that, if you can do this calculation, you can get it. I would like to write not in terms of the root, since square comes there. You can write as it is. So 12.5 centimeter square, convert in terms of the meter, MB square equal to 12.5 times 10 power minus 4 meter square. So this is the value of MB square. Substitute that value at here. The value of MB square, you can substitute. So electric field due to B at M equal to K value 9 times 10 power 9 times 2 times 10 power minus 6 divided by MB square value. MB square value equal to 12.5 times, it's 12.5 times 10 power minus 4 meter square. So if you can substitute and do the calculations, you can cut that values. So final result you can get as electric field due to B at M equal to 1.44 times 10 power 7 Newton per Coulomb. So this is the final resultant magnitude. And where is the direction? To mention the direction, here if you can draw an imaginary coordinate system or imaginary directions. So this you can mention as north, east, west, south. To show the directions, I am taking this help. So this is the direction along in this direction. So we can say the direction of the electric field at here in terms of northeast direction. So direction is along northeast. So that is the resultant electric field. Of these three system of charges at midpoint of an isosceles triangle. So here it is, the electric field is a vector sum, and we need to mind what are its charges, either the positive or the negative.